Hey project. Oh, whoa, let me turn it off. Okay, that's better. That was the one last thing I was just doing and I saw project say hi. So let's go. Hello, good morning. I am the Down Under Maker. My name is Phil. Today we are doing lots and lots of random stuff because basically there's lots and lots of random stuff that needs doing around my workshop. We are going to be talking about prototyping and how I do it because there's lots of different ways to do it, and it's something that's been of interest to my students, so I figured it'd be a bit of interest to you guys as well. I'm going to talk about iterative prototyping and making quick changes to parts before you print them so that you can further test things with an existing file that you already have before actually going back and editing the source file and things like that. So let's get started. Random stuff, that's your life. It certainly seems to be some of your streams sometimes, projects. So, what I've been working on. DIN rails. Now this is a modified version of something I found on printables. The version I found on printables was not printing quite right, so I did some tweaks to make it stand up on its end. Let me go to my other view. There we go. So that when I print them, they stand up on their end to make them print a lot better. But minimum layer times was starting to be really, really annoying. For those who don't know what that I'm talking about, oh, my Pezlis mug, by the way. Minimum layer times are a process that's built into a lot of slicers to help with print quality by slowing the printer down to make sure that each part gets to finish cooling before the next layer is printed on top of the previous one. And when your parts get particularly small, it starts to mean that the printer just has to slow down, full stop. And your print will take the same length of time, regardless of how many of the things you're printing at that layer height. So it turns out that on the Prusa, without making any significant changes, I could print 3 in the same time I could print 1, because effectively the way the algorithm works, the total layer time was best at about 2 3/4 objects. So I threw in the third, and for a 10-minute time penalty, I got 3 instead of just 1 of these rails, because they're printed this way. And that means that, yeah, very short layer per unit. But adding them together means that I could print at basically the full printer speed without having to stress about it. Now, let's talk about my prototyping. Oh, people are messaging me. This is what was coming out of my the previous version that came straight from printables. It was supposed to be printed this way, and that just doesn't work. It ends up all stringy and horrible and nasty because the bridging isn't designed very well. They didn't take into account a few pieces of the geometry for making it bridge, so it just came out yucky. So by changing the geometry ever so slightly this way to give it a slightly taller cross section, it meant that it had enough surface area to be able to print that way. So that was the first thing I did. So in theory, this is a stronger part, and better because the layers are running this way, but it's just not practical to print that way, and it looks ugly. So that's going in the bin. Next, if you're printing things to go onto DIN rails, you need to build something that's actually going to latch on. So I've been working on a system to allow me to do knockoff Wagos. This is the one that I found on printables, which sort of works, but it's not big enough in this direction for the knockoff Chinese Wagos that I buy, because they're a quarter of the price of the genuine German ones. So they don't fit. These are about 9.7 millimeters tall, and sorry, 7.75 millimeters tall, and these are 9.85 millimeters tall. So they just don't fit. But I printed that to see how it would work and to make sure that it would latch reasonably well onto the DIN rails that I've been printing. So it was working. It seemed to work all right. The two work together. Sorry about the screeching noise if you can hear that past the noise filter, but it's worth it. We're going to get there in the end. Next, I decided to start working on prototyping these. These are narrower versions for the 2 wide. And this was the first one I actually did. I just went, let full send, sent it, and realized at that point that the Wago is too tall, doesn't fit. So put that to one side. I think I actually printed both of them at the same time just as an experiment. That's maybe what I did. So then I started prototyping just that, which is a modified version of the cup to see if it would fit. I got my calipers out. Where are my vernier calipers? Here. And these normally measure about 9.85. There's a little bit of variance. There we go, 9.83 vertically. So I made my cutout in here. I think 0.2 millimeters bigger because I wanted a little bit of tolerance, but they're too loose. So I shrunk that by 0.1 and still it's a better fit and it's just starting to grip the part, but no. Oh, maybe that was the first one. Yeah, but anyway, you get the idea. Things just weren't quite the nice interference fit that I've been looking for. Maybe there's another one over here still. Possibly. I can't see it easily. So I eventually got to the point where I had one that was fitting nicely, working, and I got it to the point where nice, snug interference fit. So these pull out and they press in, but they're not going to fall out. So these are now very, very securely held. They're not going to fall out in a hurry. So I got to that point. Then I wanted to do it so it was modular. Big thing about the way I do things, I like to make it so that if in future I need a slightly different version, I can do that. So what I did was, rather than printing these and these as a single piece, I separated them. 2 reasons. Number 1, these, because of the way they're designed, have to print that way up. Otherwise they don't work. They rely on the geometry of the layers being this way so that you get the flexible locking part there. So yeah, that was part of the design requirements, was I needed to keep the layer lines that way. By doing that though, you can't have this nice snug interference fit that holds these into place, because what happens is the layer lines going this way, they start to crack. There's not enough layer adhesion to be able to hold everything snug if you do it that way. That's why all of these parts are printed this way, so that I get concentric rings of extrusion effectively to hold onto these parts nice and snugly. Like that. So, next part was to design a way to get this and this to attach to each other for the minimum amount of fuss and materials. What I came up with in my head, I went through 4, 5, 6 different iterations. None of them really worked when I went to CAD and started playing around with them. But what I eventually came up with was this. 3mm hole, well, 3.2mm hole through here, which is clearance for an M3 screw. And then a 3mm hole here to allow a screw thread of an M3 screw to screw into the plastic. Not completely happy with that yet, but it is a proof of concept. The other thing that if you've been looking closely, you may have noticed, there's a notch here. Well, it's actually a spike. It sticks out from the part, and there's a corresponding notch in the DIN rail part, which it locks into. What that means is by the time you've screwed something in here, that's actually pretty reasonable and supportive. Now, you're going to ask me, why do I have all of this unsupported part here that's not actually screwed down? Reason being, potentially I want to be able to have this part as only two. So I'm going to, hopefully when I get my act together, get this all sorted out. So I'm going to have 1, 2, 3, 4, and maybe even 5 available on my various printables and MakerWorld kind of accounts, so that people can use them. And I don't want to have this tongue on here. This is a legacy from the part I borrowed from. I don't think it's actually serving any significant purpose. Maybe it is, maybe it isn't, but that's for future testing to determine. Now, hi Nick. Sorry, I missed you coming in. We're just talking about me and my prototyping and what I've been up to in the last 2 weeks since we spoke last. I'm building a DIN rail mounting system for a whole bunch of electrical gear that's going into my Ender 5, and this is the prototyping process I've been going through. So this is the most up-to-date version of the clip that I've printed, but not quite tight enough. It's close, but not quite. Now, I've been thinking about this. There's 2 ways I could potentially deal with this situation. First way, I could potentially put some means of tightening this using a screw, but that goes against the design ethos of keeping this as simple as is reasonably possible and as few materials as is reasonably possible. So, not going to work for me. Other possibility. Let's just do it in the slicer. Let's adjust the size in the slicer. So this is my parts that I've been working with. Now, for those of you who don't know, if you import a unit part like this, where it's one piece, effectively, as far as that's one contiguous STL, if you go into your slicer and right click on it, you can almost always go split. Depending on what you're doing, if it's a multicolor, you would probably split to parts, because that then keeps all the objects in the same orientations. But if you split to objects, that then makes these things independent of each other. So I do think I need another one of these, so I am going to print it anyway. But this is what I need to work on. Now, sorry, I forgot to put you onto my slicer. There we go. Let's move you over to the slicer. It'll make a lot more sense now. Okay, let's start from scratch so I can actually show you. So I'm importing this Tinkercad file that I've been working on, and I'll show you the Tinkercad stuff in a minute, because it has been a little bit of a mission to get here. So here's the 2 parts. This is one contiguous STL that I've exported from Tinkercad. I'm going to go split to objects. There we go. I'm not sure if that actually shows up on the screen, does it? No, you can't see my pop-ups because the way the Super Slicer and Prusa Slicer, etc. work. Pop-ups don't show on OBS. But anyway, I get if I right-click on it, I get a pop-up window and it allows me to split the parts. That's what I've done. So now we have 2 individual parts. This part is fine. It actually meets all of my requirements at this point. This part was a little bit too loose on the DIN rail. So what I'm going to do is I'm going to find the correct dimension, and that is the correct dimension. And I'm going to change that to 99.5 and make it ever so slightly smaller. So it's now ever so slightly smaller in this direction. This means that I don't have to go all the way back to Tinkercad and change the file. I can just come here and do it and keep working with the file I've already got exported. Saves a lot of time. That, I think, is going to be all I need to do. Oh, okay. Something that a lot of people may not know about the latest generation of slicers. Sometimes you'll get STLs that are broken. There's a fault within the file. I'll actually, let's go to Tinkercad and I'll show you, I think. That one. Okay. Tinkercad is an imperfect solution to our problems. If you have a look at these lines, these are actually flaws in the surface from where the rendering engine in the Fusion Tinkercad backend is holding these parts. So those surfaces are incomplete for some reason. Don't know why, they just over time build up, especially when you've been doing as many iterative changes as I have, as you can see here. So these flaws in the surfaces build up, and that can lead to the STL being a bit broken when you export it. So let's go back to my slicer and get rid of it on my screen too. There's this orange triangle which says things are broken, and it also appears down here. It says one open edge. So what the slicer has done is it's identified that there's actually a flaw in the file, and it can see those broken edges. They don't actually show in this rendering here. Oh, maybe they do. Maybe it's that little imperfection. There's actually an imperfection showing here. So it is actually showing us where that imperfection is. So if we now click on the triangle up here, I think we have to do it. There's a fixing engine built into Super Slicer, Prusa Slicer, and I assume Orca and Bamboo, which then goes through, opens up the mesh, and then fixes those flawed surfaces. So that's fixed that for me, and I don't have to stress about fixing it in the CAD. What I'll do is, what you can do then is you can export this file as an STL back to your desktop, and then you can upload it to GitHub. So you can use that engine to fix any files before you upload them to GitHub, etc. So I just realized you guys can't even see me in this view. So let me fix that. There we go. That's better. I turned a few things off while I was playing the other day to do something. So what we're going to do now is we're going to go add a brim. We're going to print it on speed mode because we don't need to worry about anything really strength-wise and from where I've set it up. Slice now. Sliced. Let's just make sure it looks normal. Let's go through layer by layer. First layers look like they make sense. Now, one thing I am considering doing is changing the number of walls to be 3, because that might also help with the strength of that hinge. So let's just jump into print settings, perimeters, vertical shelves, and change that to 3. And slice again. Yeah, I think that's going to help significantly with the strength of that spot. Send to connect. Now you can't see the pop-up, unfortunately. Confirm. But if I go here, will it load? Okay. Maybe? No? No overlay surface, it's not working. All right. let's get rid of that anyway. Don't really need it for now. So let's go back to Tinkercad and have a look around what I've been doing. Now, I was having a chat with Clownhammer on somebody's stream. It might have been Zombie stream or the Lee Marie stream the other day about Tinkercad and some of the new features. I'm going to just... Oh, hi, Clownhammer. I was just talking about you. So, jump back in. Let's have a look through these new features that have come into Tinkercad. Now, up until very, very, very recently, Tinkercad used to not really have nice curves. They've slowly, after much complaining and whinging from teachers like myself, given us a few little crumbs of improvement. Now, when you automatically generate a cylinder or a circle in Tinkercad, it gives you an object which has facets. Let's zoom in and you can start to see them. Can you see these little lines? It's actually generated that as 48 flat surfaces. Now, up until very recently, you used to be able to stretch it up to 64. Now, they can give you 128 facets, which is a significant improvement in the resolution of curves and is making my life a lot better in some respects. So, the other thing that they've done is, well, one of the other things they've done, it used to be that it was really hard to make sure that your object was actually on the origin surface. You can see that there's a shadow where the object will sit when it hits the surface. Now you can go badoink and it will automatically land it on the surface, kind of like the slices we used to do. Now this allows us to place working planes actually on the surface of an object. So if I was to do this and then hit that, the working surface will move, hopefully. Is he going to make a liar out of me? Yep. The working surface is now floating in midair for us, which makes life a lot simpler for assembling multiple objects together and then being able to work in three-dimensional space. One of the things I often do when I'm building things in Tinkercad, because I have to work with Tinkercad quite a lot for my students, is I will assemble something and then realize I'm going to use positive and negative primitives, and there's a certain order of operations I have to apply them together in order for them to work. So what I can do now is I can drag all of these objects up to a specific plane, and then I can use that plane to assemble them to make life simpler. So let's get rid of that. Now, let's show you how I've put these pieces together. Remember back at the beginning of the stream, I was talking about designing these. In order to do that, that's actually a whole bunch of primitives that have to be amalgamated in Tinkercad. Why do I do it in Tinkercad? Because I wanted to play with all the new features. So let's talk about this. Let's build one, in fact. Tinkercad doesn't have the ability to do normal extrusion like you used to in Fusion. It doesn't have constraints and all that sort of stuff yet. Clownhammer, they're coming, I've been told. One of the trainers said they're coming. So, if I want to put a fillet onto a corner, I have to build that fillet. Now, what I've been doing, and I actually have a library of these files on another account because I'm running out of space on my accounts. I actually set the number of sides on my cylinder to 128 to make it as round as possible. And then I make my cylinder that's a negative to the diameter of the radius I'm looking for. That sounds strange, but this is important. I am looking to make a radius. I'm looking to make a quarter corner, basically. So what I can then do is, this one is 6 millimeters by 6 millimeters, which means it's going to give me a 3 millimeter radius. I can then line that up on the corner and then use that to cut out the corner of that cube. So what I've got is I've got a library of these cubes on another account. So I've just made that into a 6. I'm going to make it into a height of 1. I'm going to make it a negative volume. I'm going to shrink it nice and small. I'm now going to rotate it 45 degrees. I'm going to raise it up 19 millimeters. And basically what I've got is a bunch of blocks built like this with 3, 4, 5, 6 millimeter in the corners. That should actually be a 3, shouldn't it? Yeah. Control Z. Control Z again. Let's grab that object, change it to a 3. Let's chuck it back on the original build plate to, there we go. Raise it up 19 millimeters. There. Grab them all together. Now, what this button does is it groups all those parts together and puts them together. Hi, Steve! I'm going completely ghetto CAD for everybody today, Steve. So you cover the Fusion, I'll cover the Tinkercad, because I'm going to play to my strengths. I'm not going to even try and compete with you and your Fusion knowledge. But I do a lot of teaching for Tinkercad, so that's what we're working with at this point. I'm just showing everybody that we've now got a whole bunch of new features that have been built into Tinkercad now that they're merging the two engines. Tinkercad and Fusion are now sitting on the same cloud services. So let's check out this next piece. I'm going to need to get rid of myself for this. Give me a second. Camera, turn, is it that one off? Yep, that one. Now, top right of the screen, and this is what I was talking to Clownhammer about. You can now send your files all over the place to any of these locations direct, or you can send it to Forma or Fusion. You can also, if you're set up, you can also export it to Fusion this way. My understanding is it's exactly the same. So that will then throw that across to my Fusion account, and then it will be available in Fusion for me to work with if I need to on my Fusion Cloud account. So let's jump back into that file. Now, the beauty of it there is, as of the next version, I've been told it's not actually turned on yet for everybody. As of the next version, I'm told that you'll be able to then grab the mesh, convert it back to a single step, and then you'll be able to apply your fillets and chamfers and things using the normal Fusion engine. Which will mean that we can no longer, for the most part, I'll no longer have to use these special negative libraries that I've built to do all that. But there, things are coming Tinkercad wise. Now, the core one is finally warmed up, so that's good. Speaking of the core one, let's go back to right after, well, actually during the last stream 2 weeks ago, this came in the mail. Knife blade. AliExpress have elevated me to this super mega high profile VIP status, and at random, if I click on the links quick enough, I get to buy things for insanely cheap amounts of money. Like this build plate was $6 US. This side is standard PEI, and that side is one of those fancy PEO. You can actually see it through the glare. One of those fancy PEO for about $6 US. I think it was about $9.50 Australian. So yeah, the other thing I got the other day was a NeoPixel strip for 40 Australian cents. So what's that, about 32 US cents delivered. So yeah, if you buy enough crap from AliExpress, they start letting you buy stuff at crazy, insane discounts. Presumably they're clearing out their warehouse. So where are we at? We have our new iteration of our knockoff Wago holders and the printer. Another example of my iterative process. Let's see if I can zoom in without this getting too crazy. That's the meat. This might get super grainy and unworkable, but I'll leave it there, and hopefully you guys it's pretty clear. So I've been working on a modified Rapid Burner mount to allow it to take the APUS2. APUS2, amazing extruder on paper, but nobody's ever bothered to build anything to support it. Like, there's no mounts for it on most toolheads. There's a really jank version of a stealth burner adapter, but it doesn't make sense and doesn't work because you can't screw it together. Greenbeard says, projects in Dad's Garage, it did what I needed initially, but I don't want to spend time learning 2 packages, so I moved to Fusion. I have to know both packages because I teach Tinkercad and I teach Fusion, so it's kind of a needs must for me. And when it comes to Fusion, honestly, for the most part, I am usually fumbling my way through because I just haven't had enough time to be able to sit and work with it at my pace. I know full well my brain is not wired for its workflow. I've watched my students have the same issue. Some people take to Fusion's workflow really, really easily. Some people will always hate it because it just doesn't suit the way their brain is wired. And that's fine. I offer those kids OpenSCAD, and there's another one that the school's using, which I forget the name of. And quite often they will take to those workflows just as well. So honestly, projects, if you're finding that it's a complete brain melt, try one of the other packages and see if it works better for you. You got an APUS extruder, no clue what to do with it. That's the problem I've had, Clownhammer. So let's get rid of this because this is in the way. Oh, I did end up putting Allen keys. This is another part that I did my prototyping on. I found a mount that was close on printables. I chucked it into Tinkercad and I stretched it. that gave me what I needed in terms of a suitable way to work with it. I then decided to get clever, and rather than modeling the whole thing, I decided to do something I'd seen, I think it was Steve do, and a couple of other people I've seen do it. Model half and then mirror, so to create a full. Problem was, when I did it, I didn't realize that there was a 0.1 millimeter gap between these two pieces, and it printed it as two pieces. And as a result, wasn't completely what I was after. So I went back, I redid it, I moved those two parts closer together, and it did slice it as one contiguous piece, and that's what we needed. Now, reason I needed to do this, the APUS2 doesn't mount its motor at exactly 45 degrees, it's more like 50. So 45 is about there, this is about here, this is this way. So there's a difference in angle for most of the conventional mounts, and it doesn't line up. So that's the normal mount. I just printed it out. It just doesn't fit. So that's where this came from. Now, reason for all those parts. I have been working on a means of securing the APUS2 toolhead together with the rest of the Rapid Burner, which is difficult. Let me take this screw out because this is the key to it all. Now, I watch a lot of cutting edge engineering, and while I was watching one of his back catalogue the other day, I saw that in industry it's quite a common practice to actually have a big bolt or a big spacer that screws into something, like basically like a giant Nero snack grub screw. And then you have another one that's actually drilled into the threads and then tapped so that you can actually lock that bigger grub screw into place. So I took some inspiration from that, and I built into the dovetail part of this mount that I found online a screw hole. And all of these parts are basically iterations of me working out exactly what height to put that screw in so that it will nicely interference screw into here and bind enough on this to prevent it from coming loose. So it actually locks into place quite nicely using two sticky outy teethy pieces. That was part of the original design. And then actually you need to make sure that it's sitting all the way home before you put the screw in, because otherwise it will not allow it to sit. Very gently, very carefully, until it just bottoms out. And that's now rock steady. So that allows me to join those two pieces together on a very, very secure method while maintaining the Rapid Burner's mounting mechanism and using the correct way to mount the APUS2 and merge them all together. That was a couple of hours of head scratching to get all that together, but I think that all works quite nicely. So that then allows, assuming the wires are tucked in the right way, and it just fits under the cowling. There are folk who work magic in Tinkercad projects. You should see what some of my students pull out of a hat when it comes to Tinkercad. If you give a kid something and don't tell them it can't be done, they will find a way to do something. It's amazing watching some of these kids work. So I give them the tool, and if it works for them, I let them go. So we now have a secure way of mounting our APUS2 to our Rapid Burner. Now, I just need to remember which one is which, because if you remember at last stream, I was having one of those days, and I actually broke the cowling. And while I did that one, I think, and while I did glue it back together with some acetone welded it, it just doesn't feel quite right. It feels a bit flexy. There, that's the one. That's acetone welded. So I did print a replacement. Hi Brad, how are you? So, where are we at? That's me talking about all this prototyping stuff I've been doing. The one thing I wish about this Core 1, and I do love it as a machine, it's growing on me quite significantly now. I've got past all the clogging issues. Incidentally, I did end up taking a power drill to that filament that was stuck down the nozzle. That was the only way to get it out. But I was exceedingly careful, and I had the drill held in a vise, and I very carefully held the nozzle and pushed it down onto the long drill as the drill turned very, very slowly, just to very slowly, carefully drill out that filament. There was no other way it was going to get cleared. It had clogged all the way up to almost the top of the neck of the extruder nozzle. It wasn't going to be melted out in a hurry. Yeah, it was just the only way to do it practically. But yeah, it is growing on me, all the clogging aside. Now this filament is that filament that I showed you guys that got too narrow. Oh, that was one of my prototypes of the DIN rail. I printed it at 3/4 scale to see if it would actually stand up while I printed. So that can go in the bin. Those can all go over there out of the way. Those can go out of there out of the way because they're for genuine Wagos. Where are we going with all of this? Well, the other thing I've been working on is my Ender 5 following printing the first round of the roadie trucks. It's starting to show its age. It drastically needs some help. It's been a bit of a Frankenstein keeping it going. So I got to the point where I was like, this needs some help. If I'm going to keep it in my fleet, which I do want to, it was my first printer. You know how you get a little bit attached? There's an Ender 3 sitting here that I'd get rid of in a heartbeat. But the Ender 5, it was my first printer, and I do want to keep it purely for sentimental reasons. It does print okay, but it's getting tired and it needs some help. So I've decided that the Rapid Burner is going to go onto it. It may eventually get a Mercury motion system, but maybe not. Its motion system is fine for what I use it for. But what it does need is a lot of help with all the electronics. Nice mug. Yeah, Pesley's mug. Well, where's the camera? There. So let's grab this Ender and I'll give you a little bit of a tour of it. So that's unplugged. Make sure the network cable's unplugged. Yep. I'm just unplugging the screen. And then I'll roll it over because I don't want to, of course, crush my expensive Big Tree Tech screen if I can avoid it. Oh. And I'm just taking off my tool rack, which I'll show you guys in a second, because it's actually a pretty decent solution for Ender 5, and it's what one of my students built for an Ender 3 at school. So let's just put this down for 1 sec, and I'll show you that, because it's one of my students who did a really good job actually in Tinkercad. So I had a design competition amongst my students to build something that would hold all of the standard tools that Creality send with a printer. You got your spatula, the 2 spanners, the needle for clearing the nozzle, There's a screwdriver and a set of 5 Allen keys. And the design competition was to come up with a way to store them compactly on the printer so that they were easily accessible. And the kid who came up with this, it was about 2 or 3 years ago, he did a really good job. The things I critiqued were I would have ideally preferred to have radiuses on there and there just to make them not sharp, but functionally and actually using it, it's fine as it is. So he won. The one thing he did was he picked Phillips head screws for his design, so I went with it, partially because that's what we had in the drawer at school. And then all of these, we printed 5 of these. 4 of them were for the fleet at school, and then I kept one for myself. So let's get rid of that. You had to file the end of your scraper. Mine came with a sharp bird edge. I've seen that before too. Oh, buy some merch. Yeah, that would be awesome. Now, I am one of those people who gets lucky on a regular basis, and that's what's helped support the channel quite a bit. This build plate, I actually won something else from Big Tree Tech, and they couldn't supply it. Oh, I won the Panda scraper off Joel's big charity stream. They couldn't supply the scrapers for the best part of 6 months, and I was told I could either wait or I could pick something else from the Panda range. So I picked a build plate. So yeah, that's why I've got the little bamboo build plate on an ender, and it does work quite nicely because I can print quite close to the edge of the plate as a result. Let's roll this over so you can see the state of the electronics. There we go. Yeah, it's a mess. Yeah, and they do. Yeah, Big Tree Tech do occasionally send me random stuff for no reason as well. The Panda Touch became a K-Touch, and I'm very happy with it. It basically sits by my bed so that I can monitor the clipper printers in the middle of the night and know when to change over prints and things like that. So yeah, Pi 3, SKR Pico, because the original Creality board, it burnt out its screw down terminals. I think I've got it here, my box of crap. No, I don't have it, but I can show you on one of these what actually burned out. The bed terminals, this all just melted on the original Creality board. So yeah. Oh, the other thing, in case people don't know, when you get a Creality board, you have no idea what drivers are actually on it. You have to read that letter. That letter is a C on this one. That letter tells you that these are 2209s and that sensorless homing is available. I thought Pico for Pi mounted in them. No, Pico doesn't fit. Oh, on them. You can mount them on them. I don't like to do that because it means that you've got basically no access to any air when you do that. So it was a non-starter for me in terms of doing it that way. So let's get rid of this for a minute. Actually, let's not. Let's show you a couple more eccentricities of this printer. At some stage, somebody said to somebody at Mello, oh, Phil's good at prototyping stuff and beta testing stuff, and I got sent that set of buttons. Never used them in anger, but they're macro buttons, just like the Big Tree Tech version. Sorry, I got distracted then for a second because there's a rocking nut just slid down one of the extrusions. So yeah, I've got that macro button set that we can play with as we progress with this rebuild. And the other thing I've done is I've stolen Steve's trident feet to make this a bit taller and inverted the power box. There's a very good reason for inverting the power box. It lets me access the electronics, i.e. the power supply and the mains content, without flipping the printer over every time. It means I can access that from the front rather than dealing with it by flipping over the printer. Because this bit sucks. Oh, let's put it back the right way up for a minute. There goes that nut again. And let's put it back on the bench. Why? Because again, I've been playing. Now, will you be able to see it on camera or not? Maybe not. Maybe on side camera? You can see the marks from that bad ABS that I had that had what we believe to be co-PE in it. And it's actually showing in the surface on that because it's such a smooth surface. Now, this is an amalgamation of Phil playing with things and a couple of models that I saw on printables that I decided to borrow ideas from. So one model I saw as I was flicking through printables was an SKR Pico mount that actually had all of the ports labeled. Now, I'm pretty sure you're not going to be able to see this on this camera unless I mark them. So I'm just going to put some texture on here. So extruder X, Y, Z1, Z2. And then it's got all the fan ports. It's got the, the fan ports are here. It's got the UART. And it's actually raised lettering to tell you what each of those ports are. And I was like, that is such a good idea. So I decided to borrow that idea and stick it into this. The other thing I decided to do was I wanted to have the Raspberry Pi 3 for this, but I am going to, when I get my act together, make it also compatible with a Pi 4 by flipping the template for that side. And I'll publish that when I publish the models. And then I wanted a cover that sits much higher than is necessary to cover everything, but is to protect everything on the back of the printer, because this is going to be mounted on the back panel of that printer, and go from there. Now, you guys probably saw that I do have plastic panels on that Ender 5. Those are all cut according to files that the other Aussie streamer guy, you guys know the one I mean, he likes his racing cars as well. Forget his name. Teaching Tech. Yeah, so yeah, that my idea is I'm going to have that over it as a cover. So yeah, those plastic panels are all cut according to Teaching Tech's enclosing his Ender 5 project. I don't want it enclosed. I'm going to keep it for PLA, but I'm going to mount this box using those two screw holes to the back panel and go from there. What have I been missing in chat while I've been ranting on? Makes sense, and you have plenty of room. I've been looking for a used Ender 5, but people think they're gold around it. For some reason, people ask stupid amounts of money for them used. There's an Ender 5 Plus at school that I did a little bit of work on to keep it working, because they are really, really rubbish machines if they came with the original 8-bit board. So it's currently got an SKR, actually it's got the Ender 3 V3 board in it, because it was really, really irritating me. And I do have a GitHub, but it's currently private while I'm mucking around with things, and Once I've got a few more of these files organized and set up, I'll publish all my stuff there, Brad. Where was I going with this? Yeah, so yeah, I've lost my train of thought, but it's all good. So yeah, what I want to do is, oh yeah, the school one. It needed Z-tilt. It desperately needed Z-tilt. The teachers who I was working with, they knew enough about 3D printing to be dangerous, but the fine points of tuning printers was not something they had time or inclination for. So adding automatic Z-tilt to it made a lot of sense. So it ended up with an old MMU board that I was sent by Big Tree Tech to give it an extra couple of drivers. And I put independent Z on it and tuned it up a little bit. And it basically became a nice, fast piece of kit. But it's sitting there and they want to sell it and they want $600 for it. 600 Australian, which is about 400 US. It's not worth that. It's just not. But yeah, that's what they're asking, and I'm like, no. But that's what they're asking online. But nobody's paying that. They're all sitting there, and nobody buys them for months at a time. Isn't the Ender 5 the donor for a conversion? Ender 5 and the Tronxy are either for Mercury 1 or for VZBot Greenbeard. I've seen plenty of people do VZBot conversions on them. Oh, here's another one of those Ender Creality boards. As you can see, that one has, you may be able to see, that one's got a B on it. So it's got a different set of drivers, even though it looks identical. And it is the same board. It's a different set of drivers underneath the heat sinks. Let's put those away. Right. Get rid of that. So what we need to do is we need to do a whole bunch of building. What time are we at? We've been going an hour and I've got about another hour to go. So I've got a whole bunch of heat sets to do. So let's start with that. Now, remember when I had all those problems and everything was clogging up on me? I did eventually solve all those issues. We now have the tray, we now have the drawer. It does fit in here. But for some reason, it doesn't quite sit level. So what I might need to do is put some little rubber feet on it just to allow it. In fact, I spotted some rubber feet over here. Now, before I make a huge mess, let's put that there. Now, the question is, fellas, and I say fellas loosely, if there's any ladies in chat, welcome. 3 points define a plane, and 4 points is what separates us from the animals. Which way, what are we doing? Are we doing 3 feet or 4 feet? Come on, answers in chat. 3 feet or 4 feet? Is getting 2 feet at the front regardless. Waiting for somebody to reply. Am I doing 3 feet or 4 feet? Answers on a postcard. 5 feet. Hi, Beardy. I'm not doing 5 feet. 5 feet silly. But I will do 4 because that's closer to 5 than 3 is. Three for ease. You already convinced me to do 4, Beardy, so you kind of stuck with it now. So hopefully that should make this. That's a bit better. I think there's a little bit of a convex thing going on with the base. So that should be up to temperature by now. There. That didn't go right. That's going to be very hot too. If it's wobbly, you can give it a 0-star review. Hot. Maybe that's the problem. That seems to be way too hot. Oh, this is PLA. That's why I'm having difficulties. No, this isn't. This is ABS. It's ABS. I'm not quite sure why it's giving me such a hard time. Now, when I design this, I normally remember to put the little neck into the hole to let the heat set sit nicely, and I forgot. So I might go for these rubbish heat sets that I bought that were too small and use these instead, because they're probably going to fit a little better. That's better. So when you're buying heat sets for your Vorons, people, make sure you properly read all of the dimension specs. One-star minimum, like Uber. That's how I've got managed to maintain my 1-star on these streams, I think. You can't rate me any lower. There we go. Pop that in. Already got that one inserted. This is what happens when you're watching somebody else's stream instead of concentrating on designing your parts. You give me a 5-star. Thanks, Brad. Pity likes are always nice. Now, I am one of those heathens who drilled out the mounting holes on his Pi 3 to make it M3 capable. So that's why I'm using M3 heat sets, just in case you were worried. Of course, you guys wouldn't expect any less of me anyway. I think some of the issue I'm having here is that I really should have allowed for much bigger reinforcing around these heat sets. That's why they're... And I probably should have done more walls. So there we've got it. Now, SKR Pico. Oh, sorry, not. Wait a minute. It's the SKR Pico on the M3. These are 2.9mm holes to take M3s. That's what I did. Let's turn this off before I burn myself on it and put it to one side. Now. Somewhere in here, I have a stash of boards. Can't show you those, they're prototypes. What did I do with them? I had them set up, all ready to go. I could just strip them straight off the back of the end of it. I was hoping to leave that intact until I was ready to do the swap over. That's those Creality boards. Now there's a museum piece. SKR Turbo, SKR 1.4 Turbo, with the extra power bridge for running NeoPixels. Put that to one side. I'll put them in the wrong drawer. Aha! SKR Pico. Don't really want to use the Pi 4. There's a Pi 3. There's another Pico. And another Pico. Maybe even two. One. Okay, let's put those heat sets over there before I knock them on the floor. Let's get rid of that for now. What am I looking at here? I'm terrible at CAD. I know that's a shocker. Sometimes you just have to do what... Peekaboo, I see you. Okay, so this is a Pi 3 that I was using for another project. Where did I put my screwdriver? There it is. Now, I hope everybody remembers to tell Liz that they saw me using her mug on stream. Now, there's a reason I'm not using this one. It was originally a prototype controller for an aquarium, and it's saltwater damaged. So let's compare the two. Late revision Pi 3 with the Broadcom chip with the cover on it. Original version, and yeah, it looks horrid. I think the bridging on the network port hole isn't the best. No. See if that fixes it. There we go. Now I have allowed for 4 mounting screws. I typically only usually use 2. And that HDMI out, when I was doing this, is not in exactly the right spot. Could have done with being about maybe 3 or 4 millimeters taller. And I stand by leaving the opening all the way down at the base, because that just makes life a lot simpler for the geometry. But yeah, that's going to need some off-stream filing, I think, to make that fit. But we'll go with it for now. M36s are my preferred for screwing these in. Oh, a tip I was given. Nick originally recommended these screwdrivers, and they are awesome. I was hanging out on a live stream with Lewis Rosman and a couple of other guys in a Discord server, and Lewis was like, dude, have you never tried putting the magnets on them? And I'm like, okay. So I put magnet on. And now I'm far less likely to lose my screws. And then looking back on a few of his old repair streams, as I do sometimes at night to get sleep, I saw he'd been doing it on his streams for a long time. One. And they're meant to be kept outside the aquarium. When you have a large saltwater aquarium green bed, saltwater spray gets everywhere. This room, it's used to be where the aquarium was. That wall behind me used to have an 800mm tall by 2450 wide hole in it, where the aquarium went through the wall and into the other room. So, yeah. One thing Raspberry Pis aren't good at really is real-time control. That's why we use the MCU boards attached to the Pis. So what I was doing was basically a kind of a pseudo clipper kind of setup with the Pi providing the web interface, and then an Arduino doing all the real-time control stuff based on parameters that were sent to it from the Pi. So there, Pi installed. That's those feet from earlier. Put those away so I can file them later. And pick a Pico, any Pico. Now, that's the UART port, so that means it's supposed to be mounted this way around. With more M36s. It's really crazy who you bump into on random Discord servers. I mean, T-Pain's been hanging out on the Polymaker server. I happened to bump into Mr. Rosman on another. Not that you guys aren't superstars or anything. Now I think I may have not quite got those heat sets in the right spots. See if I can brute force this in. Oh, that kind of straightened that one up, so that's good. Arduino is one of those things where you have to just find a really complex project, Brad, and then take it apart bit by bit by bit by bit, and then work out what each piece does individually on its own. The other thing to know about Arduino, which isn't immediately obvious from most of the very basic tutorials, across the top of the IDE, you can actually have tabs. And I forget whether it's one tab per core or if you can just have as many as you want. So there's a lot of debate about that. But you can effectively have parallel running processes on an Arduino if you use the tabs. So you can have an Arduino will basically start at the beginning of its code and work to the end, and then repeat over and over and over and over and over again. So what you can do is, rather than having multiple things having to wait for each other, you can actually have these tabs across the top, and you can have a parallel process running in each of those tabs. You can even have the original process call those parallel processes. It streamlines coding and makes it a lot easier to follow. It's one of the things I've been trying to get my kids to do at school, but getting them to get a simple hello world kind of program going at year 8, which is what, 12 years old, that can be tough. So where are we at? Pi installed, SKR Pico installed. We do have enough room to run UART for the power, but I've been having lots and lots of complaints from that Ender about its power not being sufficient. So I bought a bunch of these. I think I showed you last stream or the stream before. I bought some of these 5 amp, 5.1 volt power supplies, which is what sent me down that rabbit hole with doing all these DIN mounts. So the idea is I can then DIN mount that using exactly the same kind of modular plate onto the top of this. Ka-tunk, ka-plunk, and it all clips into place, hopefully. Now that's probably not going to work looking at that. It's going to stick out way too far. But what I might be able to do is do some sort of modification. Let's have a look at this. So what I'm thinking is I move this piece down to here onto this end, and then extend this locking piece, still maintaining the hinge, over an equivalent amount of distance. But that one may be where I need to put a screw into. Yeah, I might need to put a screw into this to actually allow it to be clamped tight to hold it. That might be where I have to draw that line. Okay. I've been working on a NeoPixel panel trying to scroll words on it. So far I have fornicating blobs with stick figure voyeurs. Okay, that's an image. That's quite an image. So let's clear off this bench a little. So before we do that, let's just have a look. Plenty of room to allow airflow. And I've actually designed it in such a way as I could potentially do a different top with a fan hole in it if I wanted to. but I don't think it's going to be necessary. The SKR Pico and the Pi 3 both run cool enough that you shouldn't need active cooling on it for what I'm using it for here. How am I going to do this? Let's clear the bench. And let's just lay the ender down on its front and go from there. That I might put up on the ender. That can go here. I really need to tidy up my cabling. I say that every week after I finish stream and never quite get to it. Now, before I do this, I'm just going to show you one other mod I've done on this ender. This crossbar is normally at the top of the frame here. It wasn't allowing me to see the front of the bed when it started printing. So moving it down actually solves a bunch of problems. It means you can see what's going on. It also means on this different tool head, it clears the probe. And it means that if you lay it down on its face, you're not crunching the front door panel or the screen by being silly. That whack you heard was nothing important. It's just one of the HDMI cables. So let's start by unwiring some things. HDMI cable is out. Let's get all these USB cords out. Now I need to find, I've got a whole bunch of the mellow equivalent of a U2C CAN bus board for the tool head. And I'm hoping that the stars align, allowing me to basically do a stream with you guys as the launch of the tool headboard I've got sitting on my desk here launches and not break any NDAs. Yeah, I just broke that wire out of its crimp. That happens. Stepper, stepper, stepper. Right, that is a fan. Let's get rid of that. No idea what that is. It's probably nozzle thermistor. Now, that looks like it's a 1.5 hex. It is. Hope I'm not boring you guys and you're still interested in what I'm doing. So that's allowed me to get the board off here. And wrong one. So basically the reason for this setup is halfway through printing the cab for the original roadie, the electronics all started giving me grief. So I stripped them off, knocked together this spidery mount, and just screwed it to the back panel with a bit of VHB tape to stop it moving around too much. So that's that Pi 3 reclaimed. Let's put that straight back in my electronics box, shall we? Where did I put that? Oh, I have to go on the bench. Yeah. Is that just one screw? Yes, it's just one screw holding that in place. Unplug that. They are the input power. They are the bed out. That should be all easy enough to retrace back. What I need is a screwdriver to undo them. Ooh, did anybody see that? This terminal's loose. Wow, I think I'm gonna, yep, that whole terminal is loose. There's a broken solder joint. Okay, let's get rid of the ender, because I want to quickly inspect that board and see if it's fixable. I recently acquired some big, thick wire reinforced polycarbonate panels. Some workbench to give flatter work surface. Be a bit thick for that probably. Okay, let's put that wire out of the way. Let's have a look at this board. So, you may or may not be able to see this. Yeah. Can you see that terminal moves significantly? What you can't see is that the pins are also moving. Which means that those are now very, very dry joints. So, let's go to that one. Yeah, those joints are so dry. No wonder it was not happy. Soldering iron. Power on. Splash of water on the sponge. All right, that's that board all held nice and tight. And hopefully it's a level where you guys can see what's going on. So it's these two terminals here that are loose. You can see it quite well there. So they're the ones that I'm going to use some solder braid on to suck all the solder off and then resolder. That's better. Now I'm not going to make the mistake of doing both terminals at once and having the terminal fall out on me. Should be getting hot enough. Maybe my iron's dirty. Let's try some flux. Remember kids, when using flux and solder, you always need lots and lots of ventilation. The other thing that's a distinct advantage when soldering is new bifocals, and I have some new glasses coming because my prescription on these glasses is 3 years old and very much out of date. They are not the prettiest soldering joints, but they are actually joined this time. That's a bit tidier. Check this one while I'm here. That's nice and secure. That one looks like it might be fracturing. There we go. Now, you might be able to see that the casing is moving, but the terminals within the casing is no longer moving. Just going to tidy that up a little bit. There we go. Now, what do I do with my IPA? There. Now, I'm not going to lecture you on making sure you get your flux off your circuit board because it's corrosive, because it's not. An old wives' tale. I'm just doing it to make sure I can see what's going on a bit better. Yep, it's all secure now. double and triple checking. The reason I'm taking the time now is this is going to go back into my parts bin. And I don't want to be in a situation where I've accidentally blown up a board and I use this as a quick swap in and it not work. So, taking the time to inspect it now is worth my time. And behind me, the Core 1 has just finished its print run. Oh, in other news, it's almost Father's Day here. Father's Day is not this coming weekend, it's the following. And my wife, ever the organized, asked me for a list of 3 or 4 things to pick from as my Father's Day present, because then it would be still a surprise. However, she then ordered it from the list and then named it in the tracking app for the postal service, because ever the organized. So I know that I'm getting an OmniFixo 4-hand grabby thingy for my Father's Day. Now, as you can see, there's still that mark from the copy-laced ABS. But I've printed on it enough times now that it's actually kind of acting like a really good bed adhesive. It's anything I put on here sticks really, really well. So when I'm printing those really tall verticals, I make sure I place them on that spot so that they don't fall off. Now, let's go back to that original part. So this was the original part that I printed. This is the same part, exactly the same part, but scaled to 99.5% in this direction. So much more secure. While I can move it around, it takes a lot more effort to do so. So I'm really happy with that. So yeah, that even printed a bit more cleanly. Not sure if you can see it on this side cam. That one's working. Oh, that's what's going on. That camera's gone all off on its own. Did I put my mouse there? I mean, it kind of worked having it up that way, but camera 1, back at me, please. There we go. So, yeah. Now have 2 matching tongs to mount the knockoff Wago mounts, Wago thingies on. That's going to need the brim cleaning off so it lines up. If anybody's in the market for buying a deburring tool, don't waste your time with the blue plastic ones. Yes, it might save you $1, but these metal handled ones, so much more secure. They feel weighty in your hand too, so it's nicer to hold. So that all lines up. I can see straight through the screw hole here. So I know that all lines up, and yeah, that's good to go, I think. Nice. Let's get rid of that. Peel that sprue off the plates. Put the plate back. Close that. Close the door. Where are we at? We've got our DIN rails ready to go. We've stripped our SKR Pico and Pi off the ender, and we've got this plate ready to go. What we need to do next is we need to find a USB cable suitable for connecting from here to here. Hopefully there was one in amongst all those cables that we removed that will reach. That looks like it's going to be a good to go. Now, this might seem strange to you guys. I'm actually going to do it this way and around and into here. Just to keep that extra cable under control a little bit. So that's those two linked. We are also going to need a cable from the touchscreen. Yeah, that's definitely going to need a little bit of modification. That goes there. And I've dropped the USB cable that does the touch. There it is. The screen. So that's going to go like that. I think I might have some more of those adapters. I know I've got some more of these right angle adapters. I think I'm going to put a second one so that the USB cable can run like the HDMI. I've never been able to find any nicely dimensioned 180-degree offset Type-C, but this 90-degree plus another 90-degree will probably work in a very similar manner, just so that both the cables tuck in behind the screen a little bit better. So that is our heated bed output, so we may as well attach that while we're waiting. That can come off. That can come off. Let's put the screen out of the way before I break it. And leave that here. Now, I did see in my box of tricks that I had a whole bunch of Type-C cables. Another thing I won at some stage, this is actually the Founders Edition of the Big Tree Tech macro keys. That is a micro. There's a Type-C cable. Ooh, that one's an expensive one. It's got a barcode on it. I'm just looking to see if I can find one of my U2Cs or the mellow ones in amongst all this, or if it's in another drawer. It must be in another drawer. So keep this cable here for the U2C, and we're going to need another one, I just remembered, for those front cables. Oh, that one's still plugged in, so we'll leave that there for now. You have your Unraid set up and it's formatting. Yay! Like I told you privately, projects, I gave up on all that stuff. I'd rather keep the money for the power in my pocket than the energy company. Heated bed. Positive. Now, all the rest of them are suitably bootlace crimped. These power cables for the bed, though, are just too thick to be able to bootlace crimp and fit in these terminals. That's why I'm not doing it. They're not soldered. I'm not a Luddite. I wouldn't put solder on a fitting a cable like this into this sort of terminal. That might be a little bit too much wire, though. I just saw them a minute ago. There they are. Right. So that's our heated bed cable plugged in. Now, let's grab one other board so I can more easily read what's going on. Thermistors. I might have to pull up the config for a SKR I think. Let's go to Chrome. SKR pinouts. Let's go to the Voron one. Hot end thermistor is that one. I should have been able to read that. I've already got it marked, haven't I? I labeled all of these. Man, Phil, you need to remember what you're doing sometimes. Where did I put that fly cable? Let's put it down. I'm getting tired, that's what it is. Unfortunately, oh, there's the cable. Ryder had me up at midnight, so I got to reclaim an 8 GB 5.4 from Raspberry Pi NAS. Oh, nice. So what you now need to do with that is you need to very carefully set it up in one of your fast Vorons. So that is the nozzle, which is TH0. For that, I might want some pliers, I think. The Mr. Bed I probably can't do right now. I do have fan 2. Fan 2 would be the park cooling fan. hot end fan, part cooling fan is the one next to. Let's scroll down a little here. Fan 3 is controllable. That is something that I needed to know. I never got around to actually checking that part. I want to be able to set it up so that the fan that is in the power supply box is controlled from Clipper, because it's loud as F, and my plan is to put a thermistor in there and then power it off here. Actually, I'm jumping the gun. I don't need the hot end thermistor cable or the fan cable, because we're going to have a toolhead board. Why didn't you guys tell me that? You just wanted me to get there at the end of the day and go, yeah. So we're not going to be using the extruder, and we're not going to be using Z2. So where are my JST 4-pin? This is a habit I've tried to get into of late. If I'm not using a particular port on a board, plug it. Because that helps me remember that those ports aren't in use and I don't accidentally plug things in, not thinking. We're not going to be using the UART, so I need a 5-pin. End stops. Am I using end stops on this? Yes, I'm using X and Y end stops. And they are going to be plugged into here. Am I using a Z end stop? No, I'm using a probe, so I can plug that one up. That's a 3-pin, which is here. So many sockets, not enough plugs. Let's use a yellow one. Why not? X and Y end stops I'm going to need. Thermistors. I'm going to leave those open because I'm planning on running some temperature monitoring at this end, which I can use those for. And the same with the fans. I'm going to leave those open for now because I'm probably going to use at least 2 of them. So put those away. Not going to need anything on the GPIO pins at this point as far as I know. Actually, I might. Projects. What happened to building a rapid burner? The rapid burner is here. I talked about it at the beginning of the stream, but I want to get the rest of the printer running and actually operational. And then I'm hoping that the board that I've been beta testing will go public, and I'll be able to just whack that on and we can do a live stream at launch of setting up that board in real time, and then hopefully capture some of those views to help boost the channel a little bit. So hopefully that's within the next 21 days. Nudge, nudge, wink, wink. So where are we at? That's there, that's there. We're going to need power input to the Pi. I'm going to have to reprint this, aren't I? I am a huge proponent of using the USB power input of the Pis for one very good reason. There's a whole bunch of power regulator chips here. Let's go to... There's a whole bunch of power regulation circuitry here. If you power them via the GPIO pins, you lose all of that cleaning up of the power input. And That's can to lead to the instability that you see on some people's Pis. So if I'm going to be powering it off that 5-volt supply, I'm also going to need a hole in here. So I'm going to have to reprint this whole thing anyway, which means I can also clean up that. All around the stuff, you must have missed it. It's all good, dude. I mean, I'm pottering around on this and doing random stuff like you potter around on your streams and do random stuff. So yeah, I'm sure you can appreciate how sometimes your brain just goes, oh, I need to do that. And then you wander off and get sidetracked and side quest things. Speaking of side questing and things, it's come to the end of my streaming window. So let's go to that one and go away, zoom out, zoom out. There we go. We have gotten to the stage where we've got a lot done, not as much as I was hoping, but we've talked a lot and we've had some fun. I've not got frustrated on the stream, which is a first for a few weeks. And we are nearly ready to mount what will be the replacement of the... Why did it zoom back in? This is all set to off. Stay. Stay. There. Hopefully that solves it. So we are all ready to... Let's hope it doesn't zoom in on me again. We are nearly ready to mount the electronics. I need to reprint that electronics box. I'm going to reprint the whole thing in the blue so it all matches. I was a little bit disappointed in myself that I had printed it in the white anyway, but that's going to be easy enough to fix. And I can also fix the locations and the way I've done those heatset mounts. We are ready to flash the SKR Pico with the latest Clipper ROM. The SD card in that Pi 3 is already set up with the latest Clipper, so that's good. We can then, next stream, get this mounted to the back of the printer. We need to drill a big hole in the back panel to run all the cabling through the back panel above the bottom extrusion, because it was a little bit tight and a little bit short because it was passing underneath the extrusion. It'll also help tidy things up and mean I can mount some panels underneath to tidy that part of the printer up a little bit more too. And we are making decent progress. We'll plug in X, Y, and Z motion next week easily enough. We'll get all the hot end stuff ready to go. And what we might do is, if we're running really, really ahead, we'll mount an EBB36 or the Mellow equivalent SHT36 onto the APUS2, and we'll get everything running. And then it shouldn't be actually that difficult to swap over to that board that I've got sitting there when it launches. We can just do that as a separate thing if we need to. And I'm going to think about what we can do with that, because it's been sitting here for a long time doing nothing, and I think we can find a printer to put that on. So I have been Phil, I have been the Down Under Maker, I have been talking randomly in circles for 2 hours. It's time for me to hop on out of here. Thanks everybody, bye.